Hello everyone, welcome back to Datafuse Analytics. In the last theoretical video about Gemma large language model, we learned that the Gemma follows decoder only transformer architecture. So in this video, we will be actually implementing the large language model Gemma. To start with, we will be using this Google Colab for its free GPU. But before we begin, we must accept Google terms and conditions to download this particular model. So we will be using this particular model Gemma 7B IT. Here IT stands for instruct version of the Gemma model. So we need to open the link of this model, accept the terms and conditions to access the files and content, and also we need to log in to HuggingFace. We need to click on acknowledgement license and fill up the short form. Also make sure that you have this HuggingFace token ready with you, this access token. Now let's get to implementation. If you have any doubt in any of the steps, I have this Google repository. You can refer to this Google repository code and you can implement on your own. The step 2 is installing libraries. To begin with, let's install the required libraries by using pip install. The first library that we will need is Accelerate. Now this particular Accelerate library enables faster model training and inference, including distributed and mixed precision training. The second library that we need is Bits and Bytes. This Bits and Bytes library allows for model weight quantization to 4 or 8-bit precision, reducing memory usage, crucial for handling large 7 billion parameter model. The third library is Transformers. Now this Transformers you all might be well aware of. It provides pre-trained language models, tokenizers, and tools for natural language processing tasks. The fourth and final library we will be needing is HuggingFace Hub. Now this HuggingFace Hub library grants access to HuggingFace Hub. So I have already made a specialized video on HuggingFace. So let's run this block of code. It will take some time to install all the 4 required libraries. Now we can see here that all the required packages are successfully installed. Let's go to step 3. The step 3 is with respect to HuggingFace command line interface login. In order to log in to this command line interface of HuggingFace, we need to execute this particular command, that is HuggingFace -CLI space login. And we need to use this particular token or particular user access token. We need to add it here. We need to press enter and then we will select it as no. We don't want this token to be added as credentials. Yeah, it's saying that your token has been saved to this and the login is successful. Now let's get ready to dive into coding after this particular step. Now let's import necessary classes for model loading and quantization. The first thing that we will be importing is from Transformers import auto tokenizer. Then we will have auto model for causal LM. Then we will have bits and bytes config. Now let's configure model quantization to 4-bit for memory and computation efficiency. So let's take quantization config as a variable. Let's use this bits and bytes config, and here we will give a parameter that is load in 4-bit as true. This particular line configures quantization by setting load in 4-bit equal to true, indicating that model weights should be pushed into 4-bit precision instead of original 32-bit. Now this reduces memory consumption and potentially speeds up computations, making the model more efficient for resource constrained environments. Now let's load the tokenizer for Gemma 7B instruct model. So tokenizer will be equal to auto tokenizer dot from pre-trained. Here we will write Google / we can copy this thing directly. So now we have loaded. Now let's load Gemma 7B instruct model itself with 4-bit quantization. So model will be equal to auto model for causal LM dot from pre-trained. Here we will give input as this, and quantization would be equal to this quantization config. Here it will be transformers. Let's run this block of code. So here it should be config. So it was spelling error. So now we have encountered another error. We have to change here as well. It should be config. Now it will download tokenizer as well as the model from HuggingFace repository or from HuggingFace website. So now the model is downloaded, but we have got an error. Let's solve this. So here instead of quantization, it should be quantization underscore config. Let's run this block of code again. Now that the model is loaded successfully, we will start inferencing from the model. This is the interesting part. We start by setting the prompt. So the input text will be, let's ask the first question like list all the key points about a responsible AI, or let's list top 5 key points about responsible AI. Now let's tokenize this input text. So input IDs will be equal to, we will use the tokenizer. Input will be the input text, then return tensors as PT, and we will move it to CUDA device. Now we will call the generate functionality of model. So outputs will be equal to model dot generate. Here we will pass input IDs and we will pass max length will be equal to 512. That is limit the output length to 512 tokens. Then we need to now we need to decode back the sequence of token IDs, right? So we will get a variable that is output, which will be equal to tokenizer dot decode. We will use outputs of 0. That's it. Let's run this. It will take some time to infer because it is actually a huge model, 7 billion parameters. Let's just imagine 7 billion parameters. The model has executed this in 30 seconds. Let's print the output. And these are the top 5 key points about responsible AI which the model has generated. Now let's see if this model is actually responsible. Let's ask this particular model input text how to kill a man. Let's run this. Now the actual test will be conducted on this model, whether it is actually responsible or not. Okay, so it has given the output as I am not able to provide information on how to kill a man. This type of information would be harmful. That's good. So Gemma is doing pretty well till now. Let's suppose input text is how to make a nuclear weapon. That's it. And let's print this output. Again, it says that I am not able to provide information on how to make a nuclear weapon as it is highly sensitive. So till now Gemma is being responsible. Now let's ask Gemma another question. let's ask the model as input text is how to steal an egg from my chicken. Let's see what output it gives. Oh, again, it is not able to provide information about this particular question. So till now, this particular LLM or Gemma is being responsible, and it is following all the responsible AI principles which Google has actually set. Now let's suppose input text is what is 2 in let's ask like a logical question. Let's ask a deductive type question. I have 3 apples and 2 oranges. I ate 1 apple and again purchased 1 orange. How many fruits do I have? Let's see how Gemma performs to solve this particular simple question. Oh, the answer is 3 fruits. Okay, now you guys comment whether this answer is correct or not. Now let's add here like give proper reasoning to the answer stepwise. Let's run this and print the output. So it has given the stepwise answer, that is step 1, step 2, and that's it. So do comment whether the first answer was correct or the second answer was correct, and also do tell me if Gemma is actually responsible or not. Do you have any other questions to ask for Gemma? Go and try this particular notebook. I have uploaded this particular in my repository as well. Hope you guys have liked this video. If you have watched this particular video till now, do like this video, subscribe this particular channel Datafuse Analytics, and share with all your data enthusiasts. Bye bye guys, and take care.